Hey, hello, welcome to my YouTube channel. Today's tutorial is going to be on the important rules to note in differentiation, and this should be very important for you that want to write exams such as NECO, WAEC, GCE, and or if you are preparing for next year's JAM, then this tutorial is going to be good for you. Okay, the first rule that we're going to look at is the power rule, and this is the simplest of it all. For example, let's say we have y equal to a x raised to power n, where a is a constant, x is the variable, and n is also a constant. Okay, now how do we differentiate this? Now, whenever you see this, if they ask you to find dy over dx, which is the derivative, just simply multiply this power by this constant here. So we have a times n, then you write the variable down, and we still have n, but we're going to reduce the power by 1, right? Just remember, when you have y equal to a x raised to power n, to differentiate that, multiply this multiply the coefficient by the power. That we have a times n, this is an, and x raised to power n, then minus 1. So we have minus 1. Don't forget this. All right, so what if you have y equal to 3 x raised to power 5? Of course, you just apply this, right? So what's the answer now? Okay, so we have dy over dx. What do? You multiply this 3 times 5, which is just 15, right? Then x raised to power 5 minus 1. Okay, so we have 15 x raised to power 4. Okay, understood. Okay, now so let's look at these examples now. So now we have 3x raised to power 3. To differentiate this, we just have dy dx equal to, what do according to this rule? Multiply this, then reduce this by 1. Okay, so we have 3 times 3, which is just 9, then x raised to power 3 minus 1. So we just have 9x raised to power 2. Okay, so that is the solution for this one. So this one, b, we have dy dx equal to, of course, as usual, multiply these powers. So we have 4 times 11, we have 44. So we have x raised to power 11 minus 1, which is just 10. Okay, then for c, we have dy over dx equal to, of course, just multiply minus 7 times 3, that is minus 21. Then x raised to power 3 minus 1, which is just 2. Okay, all right, then dy over dx. Here we have minus 3 times minus 2, which is just minus 6. Then x raised to power minus 2 minus 1, right? So we have minus 3. Okay, we have minus 2 before, so we minus 1 from that because we are differentiating. So minus 1 from 2, we have minus 1 from minus 2, we have minus 3. Okay, so the next rule is the identity function. So what is an identity function? The identity function is the one that has its power to be 1, right, and the coefficient to be 1. Whenever you differentiate an identity function, you just have 1. So for example, when you have y equal to x, where x is the independent variable and y is the dependent variable. So if you have dy over dx, you just have 1. Okay, you just have 1. So whenever you differentiate an identity function, you just have 1. All right. Okay, derivative of a constant. This is another rule, derivative of a constant. Now let's say we have a constant. Let's say we have y equal to a constant c. So to differentiate this, if you differentiate any constant, you just have 0. So here we have, if you differentiate this dy over dx, since this is a constant, then the derivative should be 0. Okay, so here I have examples. Differentiate y equal to 6, that means dy over dx. Now since this is a constant, we just have 0. Okay, then we differentiate these two, dy over dx. Since minus 8 is a constant, we have 0. All right, then the next rule is sum rule, or I also call it term by term differentiation. Now what does this actually mean? For example, let's say we have y equal to a x raised to power n plus k x raised to power b plus and so on to c x raised to power m. Of course, the one that we have been talking about all this while is just one, right? Just one like this, which is this one. Of course, if it was this, then if you want to differentiate it, you multiply this coefficient by this power, right? So we have an, then x raised to power n minus 1, which is what we have here, right? But now we have bunches of that. Then we have plus signs in between them. Now this could be minus signs or it could be plus signs. So it doesn't matter which sign is in the front. Or let me just put plus or minus. Right, plus or minus. It could be plus or it could be minus. So how do you do this? You have bunch of these added together or subtracted from one another. Now the way to do it is to just differentiate it term by term. This is the first term, second term, then down to the last term, right? So to differentiate this, dy over dx, right? To differentiate this, just do this one by one, term by term. So here we have a raised to power n, right? Ax raised to power n. To differentiate that, you multiply a by n. So we have an, right? Then x raised to power n. Of course, since this is differentiation, then you have to minus 1 from that. We still have our plus or minus joining the terms. So this is the second term. Of course, to differentiate this, we have k times b, which is kb. Mind you, this is not kobo, right? Mind you, yeah, I know we like money, but this is not kobo. Okay, so this is x. We have x raised to power b minus 1 plus or minus, right? Joining them. Now, of course, you're going to do that till you get to the last term. Plus or minus c times m. So we have cm, right? Then x raised to power m minus 1. All right, let's see an example. If this doesn't make sense, so let's look at an example. I think that should make sense. Okay, so this is the first example. We have example A. We have y equal to 3x squared plus 4x. But of course, this is x raised to power 1. Whenever you have x without a power, of course, it's just raised to power 1. Okay, so we have so to differentiate this, dy over dx is equal to, of course, do it term by term. That is why I call it term by term differentiation. Of course, here is just a plus sign holding them together. So differentiate this first. Of course, we have 3 times 2, which is just 6. Then x raised to power 2 minus 1, which is just 1. Then plus 4 times 1 is just 4, right? Then x raised to power 1, right? Minus 1. Again, 4 times 1, which is 4. X raised to power 1 minus 1. Why do we put minus 1? Because we are differentiating. Alright? So this is just 6x. Of course, x raised to power 1 is just the same thing as saying x. So there's no need to put the 1. Okay, so 6x plus x raised to power 0 is just 1. Then 4 times 1 is just 4. Okay, so this is the derivative of this. So for the second one, which is b, we have y equal to 4x raised to power 3 plus 5. Okay, so we differentiate this term by term. So dy over dx. Of course, the normal thing is to do what? 4 times 3, which is just 12. Then x raised to power 3 minus 1, right? So we have 2. 3 minus 1, we have 2, plus, this is a constant. This is a constant. And what did we say? Differentiation of a constant is what? 0, right? So this is just 0. So we just have 12x raised to the power 2. Okay? 12x raised to the power 2. Now let's look at this one. Now let me put a slash there so we could differentiate. So we have dy over dx. Here we have 8 times 3, right? 8 times 3. So we have 24 x raised to the power 3 minus 1. We have 2, right? Plus 2 times, of course, this is x. Of course, x is just x raised to the power 1. So we have 2 times 1, which is 2. Then x raised to the power 1 minus 1. And 1 minus 1 is actually what? 0. So we just have x raised to the power 0 here, right? So we have plus, this is also a constant. Differentiation of a constant is just 0, right? So we have 24x squared plus x raised to the power 0 is just 1. The 1 times 2 is 2. Okay? Alright. So you could also play around some stuff in your textbook and see examples that you can come up with, and try to, if you find anyone difficult, just put them in the comment section below, and I'll drop solutions as soon as possible. Okay, so this the next rule is the product rule. So what if you have something like this? You have x minus 1 and everything in brackets times 1 plus x squared plus 5x. How do you do this? Of course, you could do it by multiplying this out, like just making it just a polynomial function. Of course, this is a polynomial function. If you don't know what that means, don't worry. I'm going to explain those stuffs in the next videos. Okay, so if you have two things multiplying, right, we have x minus 1 multiplied by 1 plus x squared plus 5x. Now this is a product rule, so you need to use a product rule, and the first thing to do is just to assign. You just assign each of these to another variable. Say u. So you could let u equal to x minus 1 and v equal to 1 plus x squared plus 5x. You could also interchange it. I mean, this one comes first or this one comes first, right? So that is the way to do it. Then now we have this to be u and this to be v. So we now have y equal to u times v. And the way to say this is that u is a function of x and v is a function of x, right? U is a function of x, v is a function of x. And what does this actually mean? It means that x values doesn't depend on v value, but v values depends on the x values. Okay, so v depends on the value of x and u also depends on the value of x. Okay, so with that being said, if you have y equal to u times v, how do you differentiate this? Because this is a product of two functions. U is another function on its own, which is x minus 1. V is a function on its own, which is 1 plus x squared plus 5x, right? So to differentiate this, first you differentiate u with respect to x first, right? Differentiate u with respect to x. What do you have? You have du over dx. So if you differentiate this with respect to x, you just have 1, right? Right? Because look at this, this is a constant. So if you differentiate this, you have 0. But this is x raised to the power 1, and we have 1. Of course, this is just the derivative of an identity function, right? Because if you differentiate an identity function, you just have 1. So du over dx is just 1. What about v? So dv over dx. Now, this is a constant. Differentiate it, we have 0. Plus, differentiate this, of course, we have 1 here. So 1 times 2, we have 2. Then x raised to the power 2 minus 1. So we just have 1, right? Differentiate this, of course, we have plus. Then differentiate this, we have 5 times 1, we have 5. Then 1 minus 1, we just have 0. And x raised to the power 0 is just 1. So we just have 2x plus 5. Okay, and here is the formula. So whenever you have product of two functions, this is the formula. You have dy dx equal to u times dv dx plus v times du dx. Don't forget about this. Of course, if you don't know where this came from, don't worry. Just take and hang on my lips. And in the next videos, we're going to be proving these formulas. So what is u? U is just x minus 1, which is what we have here. Right? What is dv dx? Dv dx is just this, right? 2x plus 5. 2x plus 5 plus v. What is v? V is just this, right? So we have 1 plus x squared plus 5x. Du dx. What is du dx? Du dx is just 1. So just have 1, right? So this is derivative. Okay, here I've got some examples. I'm going to be solving them, right? So before I solve them, just give it a try. Okay, so we have y equal to x squared, x cubed plus 3x squared minus 2x multiplied by 1 times multiplied by 1 minus x cubed. So first you let one equal to u, right, and you let the other equal to v. Okay, so let me choose which one should I check. Which one should I? Okay, let me take this one. So we have x cubed plus 3x squared minus 2x, and this one should be 1x cubed, right? So the first thing to do is to differentiate this with respect to x and differentiate this with respect to x. Now we have du over dx, right? Of course, we have 1 here, so 1 times 3 is just 3, and x raised to the power 3 minus 1, we have 2, plus 3 times 2, we have 6, x raised to the power 2 minus 1, we have 1. We have minus, and differentiate this, of course we have 1 here, so 2 times 1, 2, then x raised to the power 1 minus 1, we just have 0, then x raised to the power 0 is just 1, so 2 times 1 is just 2, right? So dv over dx, which is this one, differentiation of a constant is just 0, then minus, of course we have 1 here, so 1 times 3 we have 3, then 3 minus 1 is just 2. Okay, of course from our formula we know that dy over dx is u dv dx plus v du dx. So what is u? U is x cubed plus 3x squared minus 2x. dv dx is just this, minus 3x squared, right, plus, here is a plus, let me not write it here because I need to solve this one here. So we have plus v. What is v? V is just this, 1 minus x cubed multiplied by du dx. What is du dx? We have this, so we have 3x squared plus 6x minus 2. So there's the answer. Okay, all right, let me put something to differentiate that. So of course we still assign u to any of this one here, then v to any one again. So let me choose this to be x, u, so x squared minus 1, then v, x minus 1. So du over dx is going to be 1 times 2 is just 2, then x raised to the power 2 minus 1 is just 1. Differentiate the constant, you have 0, so this just goes away. So dv over dx, differentiate the constant, we have 0, and this is an identity function, so differentiation of an identity function is just 1, right? So of course we still use the same formula. Dy over dx is just u. What is u? U is just x squared minus 1 times dv dx. What is dv dx? That is just 1 plus v. What is v? X minus 1. I'm running out of space. Times du dx. What is du dx? 2x. Okay, there's the answer. So the next rule is the quotient rule, right? So the one we talked about previously is just product rule. That's when you have one function, which is this one, multiplied by another function, which is this one. But now we have quotient rule. We have one function divided by another function, right? Now the first thing to also do again is to assign this to variables u and v, right? And the way that I like to do it is that I always make the numerator u and the denominator v, right? So u, I make u x squared plus x plus 1, x squared plus x plus 1. Then v is x plus 3. Okay, and you start by differentiating these ones with respect to x. So I differentiate u with respect to x, du over dx. This is u, du over dx. So we have 1 here, 1 times 2, we have 2. Then x raised to the power 2 minus 1 is just 1, right? Plus. This is an identity function. When you differentiate it, you have 1, right? If you differentiate a constant, you have 0. So there's no need to put plus 0 there. That has gone. So we have dv over dx. Now, what is dv over dx? This is an identity function. When you differentiate it, you just have 1. Differentiation of a constant is just 0. So plus 0, that doesn't make any meaning. So we just put 1. Okay. Now the formula for this is dy over dx equal to v du dx minus u dv dx over v squared. Okay, you just have to memorize these formulas. V du dx minus u dv dx all over v squared. You just have to memorize this. V, what is v? This is v. This is v. So we put x plus 3 there. Then du dx. What is du dx? Du dx is 2x plus 1. 2x plus 1 minus then u. What is u? X squared plus x plus 1. X squared plus x plus 1 multiplied by dv dx. What is dv dx? Just 1, right? Everything all over v squared. This is v, so v squared will be x plus 3 all squared. Okay, so here are examples, and I'm going to be solving this, and you're going to put the solution to this in the comment box below. Okay, so the first thing to do is to always make this u and always make this v. So we have u equal to x cubed plus 3x plus 1, and v equal to x squared minus 7x plus 2. So you differentiate this. If you differentiate u with respect to x, we have 1 times 3, 3x to the power 3 minus 1, we have 2, plus, right, 3 times 1 is just 3, then x to the power 0, right, because 1 minus 1 is 0. Why do we put minus 1? Because we are differentiating. So we have x to the power 1 minus 1, that is 0, and x to the power 0 is 1, so we just have 3, right? So differentiate a constant, we have 0, right? Then dv over dx, this is v. dv over dx will be 1 times 2, 2x to the power 2 minus 1 is just 1, right, minus 7, right, 7 times 1 is just 7, right, x to the power 1 minus 1, that is 0, x to the power 0, x to the power 0 is just 1, so we just have 7. Differentiate the constant, we have 0. Of course, here's our formula for dy over dx. V du dx minus u dv dx. Okay, so dy over dx will be, what is v? V is just this, right? So we have x squared minus 7x plus 2, okay, times du dx. What is du dx? This is du dx. 3x squared plus 3 minus u. What is u? This. So we have x cubed plus 3x plus 1 multiplied by du dv. Oh, I forgot to put v squared. All over v squared. Say all over v squared. So that's the formula, all over v squared. So times dv dx. What is dv dx? 2x minus 7. 2x minus 7. Of course, don't forget to put your all over v squared. What is v? V is x squared minus 7x plus 2 squared. That's the solution to this. In the next video, we're going to be looking at higher order derivatives. Alright, so and don't forget to click the red subscribe button this side. Alright, so you could have access to our videos, and give this video a thumbs up, and see you in the next video.